Okay, camera is focused. Um, quick summary, things that you need to know. Should be obvious, but be able to do type 1, type 2, type 3 grids with labeling for given window. I still see people drawing grids that aren't right and not labeling anything. Okay? Now, when we did it, like the day after we did it, and you're supposed to come in here able to do it, everybody's pretty much able to do it. If you're not able to do it, when you go into the test, you haven't reviewed enough. Okay? Does that make sense? Because I see on these tests, and I'm going by what I've seen. I haven't looked at any of the tests people have taken. I don't know how many have been taken by this point. But I always see people not knowing how to do these things when they get into the test, even though they knew how to do them the day they were asked to do it. Okay? If you don't know how to do those things, when you go into the test, you haven't practiced enough. You haven't reviewed enough. Does that make sense? Because you're dead in the water. You know, 3/4 of the test requires that you do these graphs. If you can't do the graphs, you're not going to get much credit in the problems. Okay? And as I said last time, it starts with the grid. And of course, you have to know which type. Know which grid with which function type. Okay? If you don't know that, you're not going to be able to even get started. Now, the problems that I sent out for practice, there were errors on the first, on the 1B and 1C. I gave you a bad equation on each of those. If you practice those, well, I'm going to send you a better copy. Okay? Better set of problems. The rest of the problems I think are pretty much okay, but there's some bad numbers on the 1A, 1B, and 1C problem, and bad functions on the B and C where I didn't edit carefully enough. And my proofreading skills aren't bad, but they're not that great, so I messed up. So if that misled you, I do apologize, but I've got a correction. I ran a set of corrected tests. I went in and put the corrected tests into the testing center. If you took it before I did that yesterday, it'll be okay because I penned in the right information. Okay. On the some of the tests that were in there, this would have been the tests that you got. Okay. Should be obvious. And if it's a surprise to you that you need to know these things, think about how you're approaching the course, because you're not approaching it in a way that you're going to learn much. Okay. And part of the course is learning what you have to do to succeed in a college level math course. What do we do? You come into class, I give you a start on something, that give you an assignment to do. You come into class the next day, and typically you're able to do it. Okay? Most everybody in here is able to do it when they come in. Something goes wrong in most classes, most semesters, between the time when you come in and can do it and the time you take the test. You haven't pulled it together. So make sure you do. You got plenty of times. You have the weekend to use if you need it. Okay, so those are two things that you need to know, and you should know that you need to know those. So that should be part of your review to make sure that you know that in such a way that you're going to be able to do it. Then you got to know basic function notation. So you can do be able to write out the formula for y equals a f of x minus h plus k. Given the formula for f of x. It's a substitution. You put an a out in front, you replace x by x minus h in the formula, and you tack a plus k on the end. We've done that numerous times. Okay. And you've got all kinds of resources to explain function notation to you if you need it in the open math and all over the internet. Okay. If you look for that, you'll get 100 million hits, 100 million different explanations of the same thing. You'll find one that makes sense to you, but you have to write it down and practice it. So I say, write things down. Write problems up, practice. Other things. Tables of construction points. Verify the table if the function is known. I call fundamental triangles a graphical key to understanding what differential calculus is about, or just basically what average rates of change are about. I consider that maybe the most fundamental thing in the course, but many other things could be also arguably interpreted as the most fundamental thing. I can make a pretty good case for this. Now, if you ask me to, there's 3 or 4 other things I could make a pretty good case for. Okay? So it's not set in stone. I'm just saying that's really important. Content of the fundamental triangle operation is really important. Okay? And I don't think anybody that knows their mathematics would disagree with me on that statement. Now, they might not call it a fundamental triangle, but I like to give it a name because it's so doggone important. It's the connection between the definition of rate of change and the slope of a graph. We did that in class last week or even the week before. We drew the connection between the fundamental triangle and the rate of change. Okay. I don't think you really have to know that connection for this test, but you're going to have to know it for the whole course. So while you're looking at fundamental triangles, think about that connection. It will come up on the next test in a way that's kind of prominent. Now I might add some more things to this list. I don't want to have to think through it all, but these are the prominent things that in my experience with tests on this kind of material, people don't prepare with. Okay? Don't assume that just because you did it correctly in class at the end of August, that you're going to do it correctly in class here in mid-September. Or even late September if you wait till Tuesday. Okay. All right. So I'll kind of keep this close because I might want to add more to it. But we do want to look at the problems. I lifted something I shouldn't have lifted this morning. If I lift it after I've done my stretches, I'm fine. So why did I lift it before I did my stretches? I knew I was taking a chance and I thought I could get away with it. It's kind of like taking a test without preparing for it, isn't it? Okay. You won't end up with a stiff foot part in your place in your back. And it'll go away, you know. But maybe not today. I can still get around. I'm happy. All right. Now, we got any more clear board? Just what I've got in front of me. Okay. We're going to look at problems 3, 5, and 2, 3, and 5. And actually, 2A asks you to construct a fundamental triangle. And I don't think I did this last time. I think I just did problems 1, 4, and 6. Okay, now 2A in this case says construct the reciprocal. I could talk. The reciprocal shape. Okay. So what do we do to construct the reciprocal shape? Hold up your fingers. Tell me what type grid I'm going to construct for the reciprocal shape. Okay. Type 3. Most of you know that. Okay. If you didn't know that, you haven't been paying good attention and you haven't been reviewing enough, but you still have time to do it. It's not that hard. There's nothing on this test that's very hard. You just have to know every step, what needs to be done, and you need to practice it. If so, you can make a really good grade. And it could be very helpful to you by the time course is drawing to a close and you got to get a final grade. Okay, well, enough of that. Okay, reciprocal shape. The rectangle is 28 by 16. The red dot is at 24/8. Okay. First thing you do is you draw a rectangle of any dimensions, but usually fairly close to a square or to a golden rectangle or something like that. Okay. I usually draw them kind of square, but they can also be elongated a little. If you want to make it tall and skinny, you can. And sometimes you're going to want to, but right now, we just look. We want a reciprocal shape. We don't look at anything else. Your first step is draw the reciprocal shape. You got to do a type 3 grid, so I'm going to do a type 3 grid without comment because I'm not going to take the time to repeat what you've already heard a dozen times. So there's a type 3 grid in a reciprocal shape. You have 6 graph points done by a rule. You know what the rule is. If you don't, go back and look at your notes or look it up. I've actually got a set of algorithms someplace on your website, and I'll try to draw your attention to that when I post the videos. I'm not going to talk about it now. It tells you step by step what you have to do these. You should know it because, again, you've done it in class. But if you don't, that would be a useful reference. Just gives it to you in basic words. The words here: left edge, construction line below the center, right one, down one, right one, down one. Right edge, construction line above the center, left one, up one, left one, up one. Okay? That's an abbreviated set of instructions, which is all you should need. And you should know that. And the way you should know that is by having drawn this thing a dozen times or more. You can draw it a dozen times in 10 minutes if you're quick, and 15 minutes if you're a little bit slow. Okay? 30 minutes if you're really slow and really meticulous. It's worth the time. Draw each of these. Draw the shapes. Practice drawing them so you can draw them in your sleep. Because you're going to have to do it throughout the course. And you're going to have to do it in the test, which is the immediate. Okay, so anyhow, okay, now we're given information. Of course, part of drawing the thing is drawing the red dot. It's part of constructing the grid. Okay. Now we know the red dot is at 28, 16. What do you do with 28 and what do you do with 16? Some people put 28 here and 16 here. Okay. Those are the coordinates. Oh, I'm sorry, it's a 28 by 16 rectangle. And I'm wanting to do the red dot. Okay, so I'm sorry. We want to do the red dot. It's a 24, 8. What do we do with the 24 and the 8? Because that's really where we want to start. We have to start with the coordinates of the red dot. And it's going to lie on a construction line because it always lies on a vertical line through the center. For 2 of them, it lies halfway across the lower edge, but it's still in the center at the horizontal center. Okay. Now, sometimes it's at the lower edge, sometimes it's up here, but wherever it is, it gives you a start for labeling the construction lines. Okay. Now, 24 means the X coordinate. That means this line here is a line where X is always equal to 24. You want to understand those words in that statement. X is always equal to 24 on this vertical line that goes through the point 24, 8. And Y is always 8 on the horizontal line through the red dot. And the red dot is important when you do transformations, which we're going to do toward the end of next week, I think, or the very, very beginning of the following week. Transformations are a big deal. That's why we've been drawing these things. The red dot tells you what H is and what K is. Remember when I wrote A, F of X minus H plus K? H is the X coordinate, in this case 24. Y is the Y coordinate at that point. K would be 8. Okay? HK is 24, 8. And we've seen that, but haven't emphasized it to the extent that I would necessarily expect everybody to remember it. But if you're paying careful attention to detail, you would have noted that. Okay? And there's only so much detail. I say a lot of things, knowing that some of them are going to go over your head. because you're thinking about something else. I could never follow a lecture. I had to dig things out of the text because my brain was always working on what I just saw. It was hard for me to listen and have my brain work at the same time. It's the way your brain works, okay? So some of you have brains that work like mine, and if you do, you have my sympathy. But what we're saying is, coordinates of the red dot. Once you know these, and now you know the dimensions of the rectangle. Okay? The rectangle is 16 units wide, 28 units high. It's always y, x. The height is governs the y coordinate. The width is what changes when the x coordinate changes. Okay. Or the width gives you the change in the x coordinate. Okay. So this is 16 and this is 28. Now, this is step by step. You would write these things and you do everything I've done here. And I don't see people doing everything I do. Okay. Well, sometimes that's good. But I see too much evidence that people aren't seeing enough detail, paying enough attention to detail. So make sure you pay a lot of attention to detail. Okay, so we got 16 here. Well, that tells us this is right in the middle. Right in the middle of this edge here is 24, right? So from here to here is half of 16, and from here to here is half of 16. Half of 16 is 8. Numbers are easy. So this has to be x equals 32. 16 plus 8. Like I say, sometimes it's a good thing you don't write down exactly what I write down. Okay, 24 plus 8. We're 24 and we add 8. And then x is subtract 8 from 24 and you get this. And that'll be 16, which is 24 minus 8. Then halfway between here and here is this line. If you remember how you constructed it, you know it's halfway between here and here. And halfway between 24 and 32 is 28. Two ways to figure that out. It's 8 units from here to here, so it must be 4 units to halfway between here and here. So you can add 4 to 24, or you could add 24 and 32, get 56, divide by 2, you get 28, okay? And then, well, it's 4 units from here to here. This is halfway between here and here. So this one I'll label up here is x equals 22. And then we label the rest. Now, I'm not going to go through all the details because I'm taking too much time to go through these details. Because there's other stuff you have to see. So this line is x equals 18. This line is x equals 24. And then you look at this and make sure everything makes sense. It's 4 units from here to here. Yeah, it's 2 units from here to here. Uh-oh. Hold on, this is 24. I was thinking 20. It should be 26. And this should be 22. I got some wrong numbers in my head. I was talking too much. Okay. Make sure these things make sense. And you see what I did? I made sure they made sense, and I saw that they didn't. I saw this is 20 and this is 18. Wait a minute, I'm going this way. I can't be right. Okay. Oh, duh. Halfway between 20 and 24 and all that stuff. Okay. You get it right. Okay, you got the graph. Now on the first problem, I say make a table for your construction points, verify this equation and stuff like that. Okay. I give you the formula. So you got to plug your x values into the formula to see that they agree. Your table agrees with the construction points. Okay. Then I ask you to wherever it is, here it is. Well, actually, this isn't the fundamental triangle. I was thinking it was. But it says make the table. So the table. We have 16, 20, 22, 26, 20, yeah, 26, 28, and 32. In other words, the x coordinates of these points. We can see them because we've labeled them. The y coordinates, well, I haven't labeled the y's, but this thing is supposed to be 8 units high, 28 units high. So it's 14 units from the middle to either edge. So we add 14 to 8 and we get y equals 22. We subtract 14 from 8 and we get y equals -6. Then we label the other y coordinates. Halfway between -6 and 8 is y equals 1. And halfway between that and 8 is y equals 4. And here's y equals halfway between 8 and 22 is 15. And halfway between 8 and 15 isn't, wait a minute. That's 14 units. So that's got to be 7 units. So that's 7 units. Actually, then this is 4.5. And this is y equals 12.5. And my arithmetic's getting messed up because 8 and 15 is 23, and that's only 11.5. That's right. Okay. Got out of the wrong side of bed this morning. My arithmetic isn't working. There it is. Okay. Now, to get those numbers, they're not so obvious if you got 28 here. You have to realize, take half of 28. Well, that's 14. That's easy. Add that to 8, you get 22. Subtract it from 8, you get -6. Then to get this number, 2 ways to get it. Half of 14 is 7. So you come down 7 from 8, you get 1, right? Or you add -6 and 8 and you get 2. Divide that by 2, you get 1. Average the two numbers. And then you're going to probably want to add 1 to 8, and you get 9, and half of that is 4.5. Then you add 8 to 15, divide that by 2, or you get 23, divide that by 2, you get 11.5. And that can happen. I don't think you're going to see anything worse than halves on this thing, but you can get those things. So we get when x equals 16, y equals 4.5. When x equals 20, you get y equals 1. When x equals 22, you get y equals -6. When x equals 26, make sure you get y equals 11.5. When x equals 28, you get y equals 15. And when x equals 32, you get y equals 22. Again, you just look at the x equals 16 line, see what y line it intersects, okay? Look at each of these numbers, you follow the line until you hit the curve, and you look at what your y is. If you've got it labeled, you're going to get it. That's how you do construction lines, and this is a little more involved than some you've seen, but there it is. Now, what's the domain? Anybody want to tell me what the 3 words you want to remember about domain are? I'd say every x value. Now, that's not a complete statement. Every x value that corresponds to a point on the curve. but you should know that it's the point on the curve. And you just say every possible X value. For this picture, the X values go from 16 to 20. And then these X values don't have points on the curve, so they're not included in the domain. And then from 26 up to 32, again, you have points on this part of the curve. Okay? So domain. I'll write out the whole thing, but I've written it out before. Corresponding to curve points. And I recommend that you do what I've done several times now. All the X values between this vertical line and this vertical line correspond to curve points, because a vertical line through any point on this yellow segment, it's the curve. Okay? Got a question? Put it up. Okay, I wasn't careful enough when I wrote down these numbers. I was thinking about the numbers over here on this side without really looking at the curve, right? Even though I'm totally capable of doing that, I wasn't, because I was thinking about what I was going to say. Okay? And, well, no excuse. I messed it up. When X is 26, the Y value is 22. The X equals 26 line meets the Y equals 22 line. Now, when X is 28, Y is 15. The 28 line, X equals 28 line meets the Y equals 15 line. And then the X equals 32 line meets the Y equals 11 and a half line. So I had these two numbers transposed. Okay. I know better, but I wasn't actually looking at the graph when I did that. If you look at the graph and see where the vertical line meets the curve, it's going to be on a horizontal line, and you're going to have a coordinates. Okay. So thank you for the correction, because see, that wouldn't have agreed if I wanted, if it was like on the first problem where I asked you, I gave you the formula for this thing. Okay. And ask you to plug into the formula and make sure these numbers are right. Now, on the first problem, the width is always going to be 4, because there's an easy way to get the formula, which we're going to do next week. And then later on, we'll worry about, not too much later on, we'll worry about what if it is 28 by 16, what are you going to do? All right. Okay. Anyhow, understand that the domain goes from 16, the interval 16 to 20, and then union that with the interval from here to here, because every point between here and here, every vertical line that passes through this yellow line here corresponds to a point of the curve. Between here and here, any point between here and here, where this line is still white, there's no curve within this window. Maybe I said something wrong, but let me write out what the interval is. The interval here goes from 26 up to 32, right? Point is, interval goes from here to here. Look at what that vertical line is. Look at what that vertical line is. Okay, what's the range? All Y values dot, 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 which means corresponding to curve points, right? Okay, well, what are our Y values? Well, we got Y values from here to here. And we got y values from here to here. That correspond to points on the curve. If you draw a horizontal line through any one of these points on the either of the blue intervals, it's going to go through a point on the curve. If we draw a line through any point between here and here, there's no curve to hit. Now, this is part of a curve that keeps going. So on the actual function, if we don't restrict the domain unnecessarily, you would have some points between here and here because this thing keeps going down and keeps approaching this y=8 line as an asymptote. So if it's continued, every point down to but not including the center line would be in the range. Okay, and you can store that away. Right now, we're just looking at the graph. So as graphed, here's your domain and here's your range. Fair enough? Okay. Well, 2b or not 2b. It's pretty much the same. Asks you to do exactly the same things, but with the exponential function. Okay. And that means that you will get either the reciprocal or exponential function if this problem occurs on the test. Now remember, problems 2, 3, and 5, only one of those problems will occur in the test. The main thing is problems 1, 4, and 6. And that's most of your credit. You won't be able to make an A unless you can do one of whichever one of 2, 3, 5 occurs on your test. But if you get everything right on 1, 4, and 6, if it's all perfect, you'd make a B. If there's little flaws in it, well, you're not going to do better than a C. And if there are too many flaws, it gets lower than that. Okay, but that's how you do number 2. And it's really a pretty easy, it's easier if you know what I just showed you. And if you screw up some of these calculations and labels, if you give me a domain and a range that's consistent with your labels, there's just a little bit of arithmetic error in your labels like I make, I'm not going to be too concerned about it. But don't be sloppy with the arithmetic. If it's all screwed up and all wrong and not even close to being right, I'll still give you at least half credit if you show me you know what a domain and a range is and have the right shapes. Okay? But you got to know that there's a blank space here and here and stuff like that. Okay. And half credit. Well, a whole lot better than no credit. Okay, moving on to number 3. And this is really simple. If you understand function notation, okay? Red dotted, negative 16, 16. The formula for any transformed function A function that's been shifted horizontally and shifted vertically and maybe stretched. There's your formula. Now, A equals 1. Since this is one of your 3 toolkit functions that we're concentrating on, you're in a 4x4 rectangle. So A is 1. H and K are the coordinates of your red dot. And I tell you where the red dot is. Okay, well, now you got to know what to do. You also have to know what the function is. It's the quadratic shape. So f of x equals x squared. How do you then get this? You start by getting f of x minus h. F of x minus h is x minus h squared. It's not x squared minus h because you're replacing x by x minus h. X is getting squared. So whatever you replace x with is getting squared, right? So I see that mistake a lot. People write down something that's kind of right, but they don't see what it's supposed to be. Okay? So you want to be sure you understand function notation well enough to understand. And the way I explain it again is x has been replaced by x minus h. So you get f of x minus h by replacing all the x's here by x minus h. It's also not x minus h squared without parentheses because then you'd just be squaring h, right? You got to have parentheses around the x minus h so the whole thing gets squared. Well, then the rest is easy. And I don't know why. Yeah, I wrote it correctly, except I didn't write the value of k. K is 16. And I did write h instead of writing the number, okay? I'm going to continue with that. Sorry if that's confusing. At the end, I'll substitute for h and k. Once you get f of x minus h, then it's just whatever that is, plus k, because right there it is, and then with an a in front of f of x minus h. So it's 1 times x minus h squared plus k. Actually, I'm using the symbols right now. It's a times the quantity x minus h squared plus k. So for any quadratic shape that's been transformed by horizontal shift, a vertical shift, and a vertical stretch, that's it. That's the form of the function. Now you've already identified A. So the formula is y equals 1 times x minus negative 16 squared plus 16. Now the 1 multiplied by this, you can omit the 1. X minus negative 16 is x plus 16. And there you have it. Okay. Now you see me do this in more or less this order a couple of times, but right now you want to lock it in, make sure it stays locked in, and not just until the test, because you're going to have to use it throughout the course. It's going to come up again and again and again. And with quadratic functions quite soon. Now again, I had the board in the wrong position. I wasn't checking it. Again, quadratic shape then in a 4x4 rectangle with the red dot at negative 16, 16. HK are the coordinates of the red dot. It's a 4x4 rectangle, A is 1. If it's 8x4, A would be 2, twice as high. We've seen that, but I'm not putting that on the test. Okay. So anyhow, HK, coordinates of the red dot. So H is negative 16 and K is 16. A is 1 since we're in a 4x4 rectangle for this function. It's a quadratic shape, so f of x equals x squared, and everything follows. You're trying to get this formula. You start with f of x minus h. And plug x minus h in to this formula for x, and here you have it. There's what f of x minus h is. Then we do f of x minus h plus k. We just do plus k in the end. And then we put an a in front of f of x minus h, and we get this. Then we use our numbers. A equals 1, h is negative 16, k equals 16, and we plug them in for a, h, and k. We get this, which simplifies to this. Okay? If you practice that 2 or 3 times, you're going to have it. Practice it a dozen times, and you're even more secure because you don't want to not know this when you get on the test. A lot of points. Also, again, it's important throughout the course. All right. We'll continue with this idea. I'm gonna have to move the camera. Okay, I think I'm up pretty close to what. Yeah, okay. There are more bullets on number 3. Exponential shape. The 4x4 rectangle with the red dot. In this case, at 16, negative 16. Well, just mimicking what we have here. The formula is y equals a f of x minus h plus k. A equals 1. H equals 16. K equals negative 16 because you just look at the red dot. There's H and there's K. If it's a 4x4 rectangle for one of these 3 functions, or even for the 4th function that we're going to incorporate, the reciprocal square, it'll still be 4x4. Go to the cube and it changes a little bit, the rectangle you use. But for these 3 functions and the reciprocal square function, that's what you got. Okay, so it's the exponential shape So f of x equals 2 to the x. That's a toolkit exponential shape. The official exponential function is e to the x, but we'll see what that means later. Okay. E is just another number. I mean, it could be 3 to the x, right? Well, e happens to be between 2 and 3. And its decimal representation is infinitely long. Okay. So we only remember a little bit of it. We don't really use those numbers much. We use properties of the function. Okay, f of x equals 2 to the x. So I'm just kind of mimicking what I did over here so that we can say f of x minus h equals, well, we get f of x minus h by replacing x by x minus h in this definition. So we're going to get 2 to the x minus h. Okay? Not 2 to the x minus h. The whole x minus h is in the exponent because x is in the exponent here. Okay? X is the exponent here. If you replace x by x minus h will be the exponent. Okay? All that makes sense? Then get narrower and narrower here, and I need more room. Okay? But we just take the 2 to the x minus h and add k, and then a f of x minus h plus k equals a times 2 to the x minus h plus k. And you want to be careful where you put the parentheses. You don't want the parentheses around k because this a is not multiplied by k. Just multiplied by f of x minus h. So we finally get y equals 1 times 2 to the x minus 16 plus negative 16, which is 2 to the x minus 16 minus 16. You probably have trouble reading that, but I think it should be obvious. You just write it, what I wrote here without the 1. Okay. Then we do the same things to the reciprocal shape. And I said the red dot here is at the point 6, 16. So a equals 1, h equals 6, k equals 16. A f of x minus h plus k. F of x, it's the reciprocal function. Let me make sure is 1 over x. So f of x minus h is 1 over x minus h. F of x minus h plus k is 1 over x minus h plus k. A f of x minus h plus k equals a times 1 over x minus h plus k. So we get y equals 1 times 1 over x minus 6 because h is 6, plus k, well, k is 16. 1 times anything is just that anything, so it's just 1 over x minus 6 plus 16. And that's all I ask. So you see, I mean, I spent a long time explaining this, and I do these rather quickly, but it's all the same. The only difference is in what f of x minus h is. And that requires that you know that the quadratic toolkit function, the basic quadratic toolkit functions, f of x equals x squared. Basic toolkit exponential is f of x equals 2 to the x, and basic toolkit reciprocal is f of x equals 1 over x. Once you know the form of the function, you just do the same thing each time. It's just that it's going to look a little different. Okay. Now there's one more problem on there that does. I said earlier I didn't do anything but 4x4s. Well, most of it's 4x4s, but there is one problem where it's not 4x4. So we want to look at that. So the last part of number 3 is okay. First of all, it's going to be your choice. Which of the 3 toolkit functions are you most comfortable with? 1, 2, or 3, which means a type 1 graph is what you use for the squaring function, right? Type 2 graph is what you use for the exponential. Type 3 is what you use for the reciprocal. Okay? So 1's going to be quadratic, 2 is going to be exponential, 3 is going to be reciprocal. Hold up. 1, 2, or 3 fingers. Everybody got a vote, I'm not going to do it. Okay, let's see, we got that, we got that. We got a couple of those. And we got another one of those. And another one of those. You're going to break the tie. Which one? 1, 2, or 3? Doesn't matter. Hold up some. Okay, 2. Okay, 2's have it. It's tied between 2s and 3s. Okay. And there's one vote for 1. Yeah, I think we just held up a sign here in front of me. So I thought 1 was exponential. Yeah, that's right. Okay. I hope I didn't confuse that anymore on the test, but okay, well, the 2's have it, and I guess 2 is quadratic. And everybody ought to be comfortable with the exponential quadratic. And a lot of people appear to be comfortable with the reciprocal, because that was the other thing people voted for. All right, so anyhow, toolkit. In a, uh-oh. Okay, it's 16x4. Red dot at 16.6, I think. Okay, well, H equals 16, K equals 6. Anybody have an idea what A is? In a 4x4 rectangle, it's 4, it's 1, right? If your rectangle gets higher, your Y values get bigger. If your rectangle is 4 times as high as a 4x4 rectangle, then you've got to multiply all your Y values by 4. And this is only one part of one problem. And I'll tell you right now, if you don't get it, I probably won't count it against you. If you do get it, I'll probably give you a few extra points. Okay? That's almost an extra credit. I'll treat that as an extra credit question, the last part of number 3. Okay? But you need to know this, so think about it anyway, because we're going to be using it. 16 by 4 rectangle is going to be 4 times as high, so your Y values will be 4 times as great. That makes sense? Yeah, I mean, if you sketch a shape in a rectangle that's 4 times as high as opposed to the original one, all your Y values are going to be 4 times as, because you're going to subdivide the same way, but all your subdivisions are going to be 4 times as far apart. Okay. You're going to accomplish that by letting A equal 4. Now, when I say the Y values are 4 times as great, it's not quite the right word to use. I'm going to say 4 times they're actually 4 times as far from the line Y equals K. That'd be the horizontal line through the red dot. And we'll see that. I'm not going to, right now, if this thing's 4 times as high, A is 4. Okay. Okay, well, f of x equals x squared, so f of x minus h is x minus h squared. F of x minus h plus k is the square of x minus h, and you add k, and a f of x minus h plus k is a times x minus h squared plus k. So I'll leave it as a, h, and k, but now a is 4, h is 16, and k is 6. Which means, I'm going to go ahead and sketch the silly thing. Got a pretty crooked vertical line there. Let's fix that. Okay, the first line you labeled is, say, the vertical line through the center of this graph. This is x equals 16. That's where the red dot is, 16, 6. y equals 6. Now the rectangle is 4 units wide and 16 units high. Which means then you'd add 16 to y equals 6 and you get y equals 22. Halfway between 6 and 22 is 14. Halfway between 6 and 14 is 10. And it's y equals. Halfway between 6 and 10 is y equals 8. Halfway between 6 and 8 is y equals 7. And this lowest line here, you don't have any points on, is y equals 6.5. Then you do your vertical lines. Width is 4, so center to edge is 2 units. That means x is 18. And 4 units in this direction gives you 14. And it's pretty obvious what these lines are. This one, which should be a little further to the right, is x equals 17. And this is x equals 16.5. This is x equals 15. X equals 15.5 here. Oh, sorry here. So it's completely labeled. We do our construction points. Over 1, down 2. We'll get to the red dot, then over 1, up 2. And now we've got us nice wobbly parabola. Okay. That wasn't very well done, but I did it quickly. Also, I'm tripping over this board. And there are too many boards. I'm not going to move it. Now I'm claiming that the formula for this function is this. Well, let's check that out. Let's just take one of the construction points just to make it halfway believable. Okay, this point is 17, 10. Okay. Now, if x equals 17, we plug that in here. And what's 17 minus 16? 1. What do we get if we square 1? 1. What do we get if we multiply that by 4? We get 4. What do we get if we add that to 6? We get 10, which is exactly what we should get. Okay? So if you were to make a table and check the table against this formula, it would work. Check the table against any estimate you make using this curve. Draw a little better one than I did, and your estimate should be close to being accurate. That's one of the first things you're going to have to totally understand week after next. So I'll probably be going over it a week from today. But there it is. You don't need it for the test, but if you show me this on the test, on that problem, number 3, last part, if it happens to occur, again, it's everything you show me about that is worth a little bit extra. Okay. Okay, then the last problem, which is really not difficult at all if you understand domain and range, is to sketch a graph with the given domain and range. So we want to sketch a graph with the domain. Oh, I thought it was a closed parenthesis. I mean, bracket. It's an open parenthesis. Domain is -4, 1, open, union, closed interval, 1, 5, range, 5, 9, union. Oh, wait a minute, I do have to get something done about my near vision. I still read paper. Sometimes I miss little things. Okay, the range is 5, 9, union. No, it's open. 13, 19. All right. Well, we need X values that go from -4 up to 9. Sorry, -4 up to 13, right? I'm sorry. Nope. Forget it. From -4 to 1. X values, we go from -4 to 1 because this is domain, those X values. Okay, so we're going to draw a window that covers all the possible X values, and all the X values occur no, we got to go up to X equals 5, as a matter of fact. Look at those like ordered pairs. Something's not clicking here today. Okay, sorry. Okay, so X goes from -4 to 1 here, and then from 1 to 5. Make sure I copied that down wrong because it's not supposed to be that close. It's -4 to -1. Didn't see the negative. That's what I get for reading off a piece of paper. Okay, -4, -1 to 1, 5. So the X values have to go from -4 to 5. They could go further, but -4 to 5 will be enough. So, am I making sense now? Because I wasn't there a minute ago. Okay. And the Y values have to go from 5 up to 19, right? Now, this distance is like 9 units and this distance is like 14 units. But the Y distances don't have to be measured on the same scale as the X distances. Because for most applications, your Y values and X values can't be represented on the same scale. Like you go from year 1 to year 10, and the gross national product goes from $20 trillion to $40 trillion. Okay? You're not going to use equal scales. Okay. Um, okay, well, whatever the gross national product is. Okay. So now we have a window. Do we understand how we got that window? Domain is X values. The lowest one is -4. The highest one is 5. And range, all your values are between 5 and 19. Okay. So the X interval from -4 to -1, let's just put X equals -1 here. Okay. It's going to do this. It's going to be an open interval from x equals -4 to x equals 1, right? And then a closed interval from x equals 1 to x equals 5. So this is an aid. I'm going to do those dots here. So we're going to have y values above every point on this interval and every point on this interval. Y values, range is 5, 9. So we got to find 9 on this thing. So let's just say y equals 9 here. And then 13 to 19. So let's just say y equals 13 here. Now, from 5 to 9 is a closed interval. So we'll have a closed. I'm going to draw it a little low, but it's going to be a closed interval here. And an open interval here. Okay, there's several ways I could draw this. I could draw any curve that goes from this point up to this point, including this endpoint, but not this one. And now I have this part of my range. I have a y value for every number in this range, right? Every number here has a point on the curve. Over here, well, I've got to get this range, so I could just draw here to here. Could be a straight line, but curves are more general. So if you want to draw a straight line, you can. Okay, that makes sense? Now, if I ask you to draw more than one graph, get something that looks like this. Draw these intervals. You could get fancy on me. You could go from here to here. And then over in this interval, go from here up to here. Every y value would be covered, and every x value. But that really wouldn't quite get it because you don't have anything for this part of the range, right? So you really can't do that. So you got to be careful how you do it. There might be a way to split things up. Of course, you could do the simple thing and just draw a curve. Up here, increasing or decreasing doesn't matter, and a curve down here. Okay. The criterion is you got to have a point. You got to have a y value for every point in the range and an x value for every point in the domain. This would be an easy way to do it, but this would be equally easy. And you draw any curve that passes a vertical line test within any one of these regions. Does that make sense? So think about that. And as long as you label your X's and Y's and get them in about the right place, your graph's probably going to end up looking a whole lot like one of these, okay? Should be an easy problem. Okay, after class, somebody asked, I'm including this in the video. We could have done part of the domain on the down here and part of the domain up here. It would still be valid, and part of the range over here and part of the range over here. And that way, an open dot for one function wouldn't interfere with a closed dot for the other. But if you just say open dot for the range, closed dot for domain over here, you would specify it. So there's just another option, and the graph that I drew here would, come out about the same. Or it could come out like this. Doesn't really matter whether the domain is specified down here or up here, or even if you wanted to be down here. Just extend these lines on, but be sure to indicate that boundary for the windows up here. So make sure these lines are dotted, not solid. Okay, so we can do our dotted lines over here and draw the intervals for our range here and here, and not to bother with the dots, but you get the idea. Just another way of doing it.